Our topic of discussion for today is ocean circulations. It's almost the first topic of your fourth chapter. So let's what we will study in today's lecture. Firstly, we will study what's actually ocean circulations. It's also called ocean currents. So don't confuse indeed that two terms. It's almost the same. And also we will study the types of ocean circulations or currents. General factors that cause surface currents or surface circulations, because there are almost two types of that currents: deep currents and the surface currents. So let's start by studying the ocean circulations. What are actually ocean circulations or ocean currents? Is a moving seawater. Simply, you can say the moving seawater that diverse or disperse. You see in the currents when if you go through the sea or you go through some type of coastal areas, you will experience the currents there. So that's actually the moving water which you see that are circulating through the whole world or through the continents. That's actually there are some cause, there are some phenomena behind these or some factors behind these. That's actually called the moving seawater, the current water, or the circulatory waters. That's almost the ocean circulation. Transfer east from warmer to colder areas. It's also the factor, the main reason behind this, that's natural cause, the natural circulation of that ocean circulation. We will study further that how these they are the reason behind these ocean circulations, so our ocean currents. So it transfer east from the warmer to the colder areas, simply from the aquatic to the towards the polar areas, and from the polar towards opposite then to the aquatic areas, or you can say the tropical areas. They are also similar to the pattern of major wind belts. Major wind belts, like we see, the winds are from the air, atmospheric pressure and the temperatures. So they have the same kind of pattern like this. Like we see, or we will study if we have in the course, that winds blow to the several continents. So these currents or these circulations are also in the same passage, but they have some different kind of criteria and different kind of phenomena behind these, or you can say they have a different pattern to follow or different paths to follow, because affect coastal climates. These also their you can say properties of the ocean circulations. They affect coastal climates, mostly the coastal climates, the areas to near the coastal climates. There is also a term gyre. Gyre, you can also say gyre, is a circular spiral world type of whirlpool which form the whirlpool form, and it refers to the circular motion of water in all the major oceans. Like the Pacific Ocean, Indian Ocean, several four other oceans. So two other oceans. So major oceans which we see, there are spiral type of form of water currents there. So that's actually gyre. So the water currents also form these kind of circulations, so that's also the form of water currents or ocean circulations. But these gyres is actually centered in the subtropical high pressure regions, where tropic of Cancer, tropic of Cancer, Capricorn areas, where the air pressure is high or atmospheric pressure is high over the sea surfaces or the ocean surfaces. So let's move towards the types of ocean circulation differentiated into other kind of currents as well. So here we have to know that generally poleward moving, like to North Pole, South Pole moving, is warm as compared with general atmospheric temperature and those of the adjacent water of the ocean. Why they are warm? To the polar areas, if we go from the aquatic or you can feel equatorial areas, the waters or the water currents or the water areas or oceans that falls near the tropical areas, they are mostly warm, because the sun rays, we have already know that the falls on this vertically are most of the time. So these water move towards the poles so that they are warm, like toward the pole. If they move the currents, they are mostly warm. But the equatorward moving current, that is from the polar areas, they are cool, because temperatures are lower than those of the adjacent or the comparison areas. That's a simply difference and major phenomena behind these currents. If we go to the water currents or more basic ocean currents, so let's move towards the other kind of factors major factors that can cause the surface currents. Here we will literally elaborate these kind of things, because here if we go for in some details it can be the chapter in itself. The major factors that can cause the surface currents are mostly the currents of the ocean currents or ocean circulations. These are wind and its frictions, the wind that cause the surface to disperse and cause its friction that cause the currents towards east or west, and then the polar areas, north or pole. Density also, as like we see in the also in the surface and deep water, the density also moves that, because density is equal to mass per volume, how much mass that is moving and per volume area it's covering, and due to that mass it disperses or it cause it to swirl or whirl and cause it to current, make the current or make the circulation of that water, that ocean water. So the next is atmospheric pressure. That's the main cause. Like we see in the winds also, winds are also caused by the atmospheric pressure and the temperature. So here is also the cause behind that wind, so also the cause behind the circulation of surface circulation or water circulation or the oceanic circulation or currents, and precipitation as well, because precipitation makes that meteorological level, meteorological cycle to recycle and also to cause the temperature balance of that surface, either it's water either it's wet or it's dry areas. The melting of pressure is also the major form of that. Like we see in the polar areas, Antarctic, Arctic Circle, and mostly we see the Pakistan example. The glaciers melting also has the major cause for that oceanic currents or oceanic circulations. The one factor here we study a Coriolis effect. It's also a Coriolis force. It's a function of a latitudinal index. Like if we saw to the east-west, like east-west factor, east-west parallels, they have also the cause behind that kind of surface currents. It's maximum at the poles. If you go to the pole area, like if pole were are parallel wise, then it will be maximum. It will be maximum the Coriolis effect, which is causing the surface current, surface circulation, and it will be minimum at the equator, like beach at बिल्कुल the mid of the equator, it will be a minimum. The temperature, like we see it can also, you can say, justified with the atmospheric pressure. The temperature, like in the wind circulations, is also the main cause of that surface currents, because it can make the water hot or warmer, or then the disperse the cool water towards the colder or the warm areas. The gyres, as we have already studied, are lots of loops of moving waters, also causing these surface currents. Also the shape of the coast. Shape of the coast, where the areas are lying, where these kind of oceans are lying, these are also making that kind of ocean currents. Either it will be surface or it will be the deep currents. Season change is also the biggest cause, one of the biggest cause behind the surface currents of circulation, because the seasonal change, like if the moon change, even also has the factor behind the surface currents. Bottom topographic of that bathymetry, or you can say the oceanic shelves, also has the reason behind that kind of surface currents. So let's move towards the how the ocean currents and climates are related or correlated. What can be the causes that making these kind of currents the making climate relation correlation with climate, and also the many effects on climate. So if here we will only give a touch to the that kind of topic, which is ocean currents, since it's not that much in that topic or your course, but here we will give you a touch to make a little bit of clear your idea about the that topic and its relation with the climate, or you can climatology. The warm ocean currents, obviously will have warm air at the coast. Like if the warm ocean currents or warm ocean surface currents or surface motion, then it will blow a warm air toward the coastal areas. It will have an effect of warm air towards the coastal areas. Like if you see in the Karachi area, we experience the heat waves. That's because of that Indian oceans, or sorry, if because that's because of the that Arabian Ocean that's falling at the Karachi area. So that's causing that kind of a warm or hot air to blow towards the coast. Because of that currents that making the pressures toward the coastal area. How the warm and humid air, if the air is humid and warm, obviously it's because the humid climate and joining land masses, or you can say warm humid currents, which is in the pressure is high, the air the currents are warm and is blowing toward the coast. It will cause the adjoining area land masses to become the humid and relatively warm. Up next is if there are cold ocean currents, obviously it will cool effect at the coastal areas. Like if you see in the night time, mostly in the night time, if the surface water or surface currents become cool, it causes cool kind of air. You will experience a cool kind of a freeze, especially in the morning time in that kind of coastal areas. If you have experienced some kind of oceans or some kind of rivers, if you have some these scenes, or if you have spent some night there, I also personally experienced. So there cause the at night time, mostly if the air blows at the surface of the currents and make the currents are making the surface, and that's and the moon is blowing over this due to the effect, due to that cool effect, making the air also cool as well as towards the coastal areas. Last but not the least, it's about the cool dry air. If you blow at the surface of the area, I would surface of this surface currents or the surface circulation of that oceanic circulation, then it will obviously cause dry climate and joining land mass, like you can see in the coastal areas. Why? If it's cool, but its effects will be drier. It will be obviously cool, but it will be drier, because the dry it feels not that much humid. The currents that causes making drier towards the surface and making it blow towards the coastal areas, making it dry, and there's a cooling effect but dry. Literally, why you can see there is a difference between how it will be warm or it will be much cool, or it will be cool but dry, and warm but humid. It's all because of the atmospheric pressure that's causing it, the winds toward that, and also cause of temperature. These mix up making that combination either warm and humid, either cool ocean currents, or either cool and dry with dry air. And that mix-up also causing the coastal areas effect, climatological effect, and also the effect on the weather system of that coastal areas, or the landside farming near or adjacent to the sub tropical areas, also you can say sub areas of that falls near the oceans. Most you can say the ocean, like Pacific Ocean, Indian Ocean, Australian Ocean, and the other ocean that are farming, are the other sub-rivers, tributaries that are farming that of areas. So that was little more about the oceanic circulation. Hopefully, we will forward toward the other topic of that hydrological chapter, or you can say that's about the water study, that's all about the hydrological study in that sense. So hopefully inshallah we will study much about these kind of phenomena. It will repeat in time to time. Yeah, you have got touch about that.